Good morning, everyone. Radhe Radhe. Mm, I think I'm audible. So, as you guys know, we are very close, very close to 2.5k subscribers. So, yeah, we are aiming for 2.5k subscribers. Okay, 2.5k subs. Guys, new to this channel, please do subscribe my channel. And if you find the content that good, okay. So nothing else. Hello there, hello. Okay. So let's start with today's post-contest discussions. Now, the first question is toggle light bulbs. So given an array of bulbs of integers between 1 and 100, there are 100 light bulbs numbered from 1 to 100. All of them are switched off initially. For each bulb in bulbs of I in the array bulbs, if bulbs of I is currently switched off, it gets switched on. Otherwise, it gets switched off. That is, it gets toggled. Okay. Return the list of integers denoting the light bulbs that are on in the end, sorted in ascending order. If no bulb is there on, return an empty list. Okay. So what does it mean? That it means that you've got a list of bulbs. Okay, you've got some bulbs. How many bulbs? You've got 100 bulbs. Okay, and there are 100 bulbs. Okay, let me write the number also. The 100 bulbs. So initially all of them are switched off. Now let's say it is 1, this is 2, and this is 3. I solved all of them. I solved all the questions. All 4 of them. I will discussing all 4 of them. I felt that today's contest was on the easier side, but anyways, like it depends. It's a very again yeah. Okay, let's say now I tell you that you switch on 2. Okay, so you switched on 2. Now I tell you that again you switch on 2. So now you can't switch on, right? So you have to switch it off. So you switch it off. Okay. Again there's a 2. So you switch on it. Again there's a 2. You switch off it. Okay. So that is what you have to do in basically in the toggle thing. So it is like 10 you get switched on, 30 explain in descending order. Explain in descending order. Yesterday's was easy. Okay. Okay, explain in descending order. You mean start from 4th? No, it's better to start from 1. Okay. See, you guys are like you guys are doing contests for a long time, but my content is like, actually for everyone. Okay, so earlier I used to solve only 2-3 questions, the last 2-3 questions. Okay, but now I start from the first question. So yeah, let's go on a sequential manner. Okay, so you light on 10, then you light on 30, then you light on 20, and then there is again 10. So you switch it off. So you switch off 10. Okay. So what are the light bulbs that are on? 30 and 20. And if it is in ascending order, then it is 20 and 30. Okay. Now if we go for this, you light on 100 and you light off 100. So there is no bulb that is on. Okay. It is very easy, the solution. Okay. I'll just directly go through the code because nothing that much. You can have a frequency for all the 100 of them, and for all the bulbs you add it to the frequency, and for every bulb from 1 to 100 you check if the frequency is 2. I mean the frequency is even, that means it got switched on, switched off, switched on, switched off, switched on, switched off, so it is switched off, right? But if it is odd, then that means that it is switched on. So if it is odd, so you just switched on, so you add I to the answer, and since you're going from 1 to 100, automatically that answer is in increasing order. Okay, I don't think there would be any doubt on this, so I'll simply move on to the next question. If there are any doubt, you can write in the chat. I'll come back to that question again. Okay. The second question is first element with unique frequency. You're given an integer array nums, return an integer denoting the first element, scanning from left to right in nums whose frequency is unique. That is, no other integer appears the same number of times in nums. Okay. There's no other integer that appears the same number of times in nums. So this is also a very similar question to the previous one. So now what you can do is you can have two frequency arrays, okay, or frequency matrix or whatever you want. One is frequency 1, the other is frequency 2. Okay, frequency 1 is going to store the frequency of all the elements in the array. Okay, frequency 2 is going to store the frequency of all the elements in frequency 1. Okay, so now that we know that frequency 1 is storing, the frequency of all the elements are getting stored in frequency 2. So for every number in array, you're going to backtrack this number to frequency 2. That is, you're going to do frequency 2 of frequency 1 of array. Of that specific number. And if it is equal to 1, that means it is having a unique count. Otherwise, it is not having a unique count. Okay, very simple. I'll just show you what I'm trying to convey. It is like you take two frequency arrays, 1 and frequency 2, then you add the frequency into frequency 1 and then the frequency into frequency 2. Okay, and then you take the numbers, and frequency 2 of frequency 1 of x is equal to 1, then return x, otherwise return -1. Any doubt on this? I'm assuming that my stream is not lagging, right? Because it seems like guys are a little bit. If you think that it is lagging, you can tell me. Okay, let me know. Rather, let me check by myself only. Yeah, I can hear myself. And things are not lagging. Okay, great. So let's move on to the next question. There are 6 people. Please, okay. Anyways, guys, like we are nearing to 2.5k subscribers. So if you're new to this channel, please do subscribe my channel. Okay. The third question is longest almost palindromic substring. Okay. You're given a string S consisting of lowercase English letters. A substring is almost palindromic. Let me check the stream quality. No drop frames. Everything's fine. A substring is almost palindromic if it becomes palindromic after removing exactly one character from it. Return an integer denoting the length of the longest almost palindromic substring in S. A substring is contiguous. You know what substring is contiguous and what is a palindromic. Okay. So it is very simple. It is given that you're given a string. Okay. I'm representing it in the form of an array. Guys, just wait a minute. Okay, I'll just bring my water bottle. Wait. Okay, so for third, we can apply the Maneker algo by initially first storing the prefix and suffix and checking one of using Maneker overall, big O n squared and big O n squared space. What if I tell you that the algo that I have used, it is also big O n squared? Like, why would you need a Maneker algo to store it in big O n squared, man? You like if you see like it is very similar to Maneker's algorithm. What I have done. But my solution is also big O n squared, okay? My solution is also big O n squared. So you are having this string, okay? So what you can do is you have to fix a pivot, okay? See, a palindrome. Let's take an example of palindrome. Use center expansion. Correct. You're correct. I use center expansion. So this is a palindrome, and even this is a palindrome, right? This is also a palindrome. But what is the difference between them? This is a palindrome of length odd. This is a palindrome of even length. So if it is odd, so we can ignore the middle element and we start the traversal from the right and the left. Okay, and we go on doing it until we find that all the elements are equal or not. The same thing is for this also, but over here the middle is not over here. The middle is in between. Okay, so one is over here and one is over here, and we go on expanding. Okay, great. I've done a similar thing. I've done a very similar thing. If you look into my code, I have done a very similar thing. See what I've done. The answer is initially 2. Why is it so? Because I know that in the, like, if it is, let's say it was given that the length is 2. Okay, it starts from 2, right? It was given. Now I can say that yeah, anything of length 2 is almost palindrome. Why? Let's say it is A and B. Is it almost palindrome? Yes, it is almost palindrome. You remove B, A is a single element, it's palindrome. You remove A, B is a single element, it's a palindrome. So it's always a palindrome. So 2 is a minimum. Okay. Then what I'm doing is I'm going through all the elements. I'm checking if I greater than 0 and I less than n minus 1. That means there is an element towards its left as well as towards its right. That is this condition. Okay, there is an element towards its left as well as towards its right. So now I fix L over here and R over here, and I decrease L till L and R are same. L and R points to the same character. Okay, and I move like this. Okay, if you look into the code, I'll show you L is equal to I minus 1, R is equal to I plus 1, while L greater than and R less than, and S dot char of L is equal to S dot char of R, L minus minus R plus plus. Okay, so till now it is a palindrome, right? It's a palindrome. So R minus L minus 1 is a palindrome. Now we again check that if L greater than equal to 0 or R less than N, that is any one of them, any one of L or R is still in range. That is, it is not index out of bounds. Okay, any one of them. Then what we know, then what we can do is we can add one element. Okay, let's say there is a string like this: A, B, B. Oh no, I'm talking about this case now. Okay, let me not include A, B. Let's say it is A, B, A, D. Okay, A, B, A, D. Now I put my midpoint over here. L was pointing over here. R was pointing over here. It is the same element. Now R points over here, but L has become out of index, right? So we break out. Correct? We break out. But the moment we break out, we are going to check if L or R, any one of them, is still in index or not. Right? D is still in index. So we know that till over here it is a palindrome. So if we add an extra element to it, then also it's a palindrome. It's almost palindrome, right? So this is the condition. That is, I'm going to check if any one of them is still in the position, then answer is equal to mat.max answer minus R answer comma R minus L. Why R minus L? Because the length of this is, let's say this is minus 1, right? And this is 0, this is 1, this is 2, this is 3. So 3 minus minus 1 is 4. Okay, and this is the length, right? So that's the reason we are going to make R minus L. I don't think that any doubt over here. Now what we do is, now we make it, if L is still in index, it is still in index and it is greater than 0. That means even after moving 1 towards its left, L will still be in index. Then we make L minus minus. Okay, and then the same thing. Okay, the same thing I repeat over here. The same thing, the same traversal I repeat over here. Why do I do this? Because this means that I'm going to ignore the L. Okay, this means that I'm going to ignore the L. So I can ignore the L. See, what I can do is, I know I can ignore one element, right? Now I can ignore an element towards its left or an element towards its right. So first of all, I decide to ignore an element towards its left. Then I will ignore an element towards its right, and whichever gives me the best answer, I will keep it, right? So see, I do this, and the same thing, L is equal to I minus 1, R is equal to, the same thing I repeat for R also. Okay, the same thing. But you may ask me that if we are repeating the same thing, why are we not doing this condition? We are not doing this condition because we have already computed it. Doing this over here would be a redundant operation. It's not a wrong answer, it will be a redundant operation. So we exclude that. Okay. Now the second condition, that is this one, ABA is okay. Now ABBA. So let's say we are at the position B. So L is pointing at B. right? So what will R point at? R will point at I plus 1. That is also B. Okay, clear? uh, Look at the solution. L is equal to I, R is equal to I plus 1. Now since it is I plus 1, so we have to ensure that it is not going to be out of index. So that's the reason we make I less than N minus 1. Now if we look into this question very casually, like which I noticed right now while explaining, that is for both the conditions we are going for I less than N minus 1. But we were doing it I less than N. So we could have directly gone for I less than N minus 1 over here only in the loop, and we won't need that, right? We would have done that. But it didn't click my mind during I was solving the question, because I came up with a completely new thing. Okay. So yeah, that is one of the things we could have done. Then we wouldn't have needed this if. It would be a direct one. Okay. So the same thing, no difference. Just the position of L and R is differing. The same thing is going to be done over here, and the same thing is going to be done over here. Okay. Any doubt regarding this, or do you think we can move on to the next question? Okay, just tell me. Should I go for members only? If it is clear, just uh, write yes. I mean, just vote yes. Okay, then we'll move on to D.
Choose Kotak 811 account खोलना 3.
Nah, man, I don't know. Like, okay, so I'll consider it as a yes only, because people are not that responsive, I guess. Okay, so the last question: maximum subarray is OR with bounded range. Okay, so given a non-negative integer array nums and an integer k, you must select a subarray of nums such that the difference between its maximum and minimum element is at most k. The value of the subarray is bitwise OR of all elements in the subarray. To return an integer denoting the maximum possible value of selected subarray. Subarray is you know what is a subarray is. You're given a nums and you give it a k. Okay, so the difference between maximum and minimum should be less than equal to k, right? That is what the question tells us. And in that subarray, we have to find uh, among all those subarrays, we need to find the subarray which is going to give us the maximum OR. Okay, that is it. Nothing else. So, what do you think is this solution about? See, if whenever we are talking about maximum minimum, we know it's a monotonic cube, right? Sorry, monotonic stack. That's my mistake. It's a monotonic stack, right? You know, the sliding window, maximum, minimum problem. Okay, it's a monotonic stack. Sliding window. Okay, it's a sliding window. Ignore my handwriting. It's a monotonic stack. Monotonically increasing or monotonically decreasing stack. So if let's not go into much depth at the initial state. Okay, first of all, I'll just show you how I've done the monotonic stack part. See, max OR, I have a max monotonic stack, I have the min monotonic stack. Max, we use a DQ because stack usually does deletions from one part, but we will be needing the other part also. Okay, so we gotta try. Okay, so no, not now. Okay, not now. I'm not going to come into this right now. Just try to understand what I'm doing. For end, R is equal to 0, R less than N. So L is fixed at 0, R is going to move towards its right, and then we are going to store the max element in the max stack and the min element in the min stack. You know the logic behind it. I'm not getting into the depth of it. It's a monotonic stack, very simple logic, nothing very hard. Then we are going to check if max is not empty and min is not empty and nums of max minus nums of min is greater than k, right? Why greater than k? Because our condition is to make it lesser than equal to k. So if it's greater than k, we can pop out elements, okay, from the first. So if it is so, If max.peak first is equal to L, that means it is pointing to the leftmost element, then pole it. If min is pointing to the leftmost element, then pole it. XOR is equal to prefix of L. Okay, not now, and L plus plus. Okay, very simple. This max min thing, it is very simple. Nothing too hard. Now, why do we need a try node? Okay, see, like XOR has a very interesting property called that it's not, I don't know what it is called actually, but it means that A XOR A is equal to 0, right? We know this. So if we have the prefix XOR, we can get the XOR of any subarray, right? Let's say if we have the prefix XOR, so the XOR of let's say XOR of, it becomes AOR, it looks like AOR. Okay, it's the XOR. The XOR of L comma R, it is going to be nothing but prefix XOR. Okay, I'm writing it as PX. Prefix XOR of R, XOR, prefix XOR of L minus 1, right? This is it. Because, okay, it may not look like L minus 1. Because we have to, like till R, we are taking all the elements. And let's say this is L. So all the elements before it, if we XOR it out, so this becomes cancelled out, right? So we get the prefix XOR of this. So that is from this property only. This is a very basic thing. Like if you know monotonic stack, if you don't know this XOR property, it's quite awkward, right? So this is the property of that. Now in the try, you know what we can do? We can insert, we can remove, and there is a calculate. Okay, usually in a try there are three operations. One is insert, one is remove, and another is a calculate. Now the calculate is the maximum XOR, the maximum sum, the maximum difference, whatever you may think of. Okay, so every try node has a child of size 2. Why 2? One is like there are two, that is 0 or 1. It may be set or it may not be set. And then there's a count, that is how many counts are there for that specific set thing. Okay, so whenever we are inserting an element, we go from the 15th bit to the 0th bit. Okay, because if the 15th bit is high, we know that it is going to produce a higher number, right? So we have to be greedy enough. So we insert it. So how do we insert it? Set is equal to x. This is just to find the set bit. Okay, so if set is equal to 0, it means that the bit is not set. If set is equal to 1, that means the bit is set, because it is x greater than I. That is we remove all the elements towards this right that are not, that is less than the ith bit, and then we make it and 1 so that we know if the bit is set or not. Okay, if we are visiting that specific child for the first time, child of set for the first time, so we initialize it with try node. Okay, and then we make the node is equal to node.child and set it, and node.count plus plus. Okay, nothing else, very simple. Node.count plus plus because it is insert, and node.count minus minus because it is remove. Okay, no big difference, the same thing. Now the max XOR. Okay, how do we find the max XOR? See, in this, what we are going to do is in the try node, rather than the try, we are going to store all the prefix XORs. Okay, all the prefix XORs. So now when we are at a specific point, let's say okay, it became a little bit awkward to look into. I think my Excalibur is lagging a little bit, but yeah, you guys can. I can't make this right. Okay, this thing. Let's remove this one. Yeah, I can't make this right. So this is the array. Let's see. So if we have all the prefix XOR stored in a try. Okay, stored in the try. Now let's say I'm at this position. Okay, R. This is R. Now what I can do is I can check out like all the tries, and I can take out the XOR which is going to yield the maximum value that I can have, right? I have to yield the maximum value, right? So how am I going to do that? Because I know the prefix XORs of all the elements over here. And I know that my R is pointed over here, so I can get all the elements from here and I can put it into R and I can check it. Because the formula for prefix XOR, the formula for subarray of XOR is very simple. It is prefix XOR of R, XOR, prefix XOR of L minus 1, right? Very simple. So we can do that. That is what we have done. Now that I'm explaining it to you, I feel that we could have done it even without using a try. Okay, we could have done it even without using a try. Can we? Can we have done it? Or I think no. Anyways, like even if we were not using a try, it would be taking a lot of no. It would be we could have done it. Okay, we could have done it. So now I'm realizing it, but it's not an issue. We're gonna use a try also. So see, if set is this, okay, let's say this is set. Now set can be 0 or 1. I told you. Set means that that specific bit is set or not. If it is set, it is 1. If it is not set, it is 0. So, like for XOR, if the answer has to be 1, so it will be either 0 XOR 1 or 1 XOR 0. All the other combinations are going to yield 0 for XOR. Okay, this is 1 and this is also 1. So if the set bit is 0, we have to take 1. If the set bit is 1, we have to take 0. So what is the best thing to check? We can make 1 minus 0 and 1 minus 1. Okay, right? We get the needed bit. So we get the need. It is 1 minus set. Now we are going to check if there is a child of node which is need or not. If it is there, then we are going to check if its count is greater than 0. That is, it hasn't been removed yet. Okay, because remember one thing, when we were making count minus minus, we were not removing it, right? So we have to check if it is present and its count is greater than 0, then result that specific bit gets added to the result. Okay, means that that bit can be made set. Okay. And if it is not so, node is equal to node dot child set. That is, we move towards its set. That is uh, the 0th thing. Okay, otherwise we move towards its named. Okay, very clear, like not too hard to understand. This is it. Now see, I skipped few things while I was explaining this, right? Why do we insert a 0 at the beginning? Because XOR of no elements is 0. Simple. XOR of no elements is 0 and it's a fixed thing. It will be there. Okay, then int I is equal to 0, I less than n. Prefix XOR, we get the prefix XOR. Okay, why do we need it? I'll tell you later. Because let's say if I'm done with this and I'm going to remove elements, what I was doing L plus plus, right? I was going to I was going one step towards its right, like left was going one step towards its right, L was going one step towards its right. So the moment it gets towards its right, so the XOR, the prefix XOR till L, till now, it has to be removed from the try. Okay, so we removed it. Simple, clear, great. Now answer to mat.max, answer comma try.max or pre. Okay, and then we insert pre because pre is nothing but XOR of all the elements till R. If we look into this, pre is nothing but XOR of all the elements, XOR of all the elements till R. Okay, so we insert it. Any doubt regarding this? Tell me. Otherwise, this is a little bit like lengthy type of fashion, but I don't think there will be any doubt for this. Oh, it seems like people have gone silent. Okay, great. No issues, man. No issues. Let's let's move on to the rating of the problems. See, since the last question I did it with try, so I will give it a hard rating. Okay, irrespective, because I don't think try is a easy thing. Okay, easy. start. Medium. The first question was toggle light bulbs. Huh? Toggle light bulbs was, oh, that was easy one. That was easy one. That was easy question. The second question was also an easy question. The third question was longest almost palindromic, considering that it was a medium question. And D was a hard question just because it used try. Okay. Or rather, let's not make it hard because it was still solvable, right? So it's over here. So yeah, that is the rating. Now this C, it may come a little bit over here also because it was a normal brute force. Okay, the C may come over here also because it was a normal brute force. But anyways, let's put it over there only. Now this looks more like a C. You know what looks more than a C? Very bad. My sense of humor is very bad. So yeah, that's it. Okay, that's it from my side. Thank you guys for joining. Yeah, one more thing. Like we are very close to 2.5k subscribers. So if you're new to this channel and if you like my content, do leave a subscribe. Do like this uh, video and comment down if you have understood everything, or even if you have, or maybe if you have a crush on me, you can comment down. Okay, that's it from my side. Thank you guys. Bye.